Okay. On your slide, you'll see the challenge question. It talks about somebody's GPA. And this is how you calculate a GPA, because you know a 4.0 means a perfect A average. Okay? That's because A's are worth 4 points, B's are worth 3, C's are worth 2, D's are worth 1. The other grade isn't worth anything. So we divide 4A plus 3B plus 2C plus D all over N. We divide it by N being the number of credits you have. We want to take a closer look at this. And to do that, we're going to look at what you call this. You actually call this a rational expression. A rational expression is an expression that can be written in the form P over Q, where P and Q are polynomials. This is a polynomial of 4 terms. This is a monomial, really, but of course it's a polynomial as well. Okay? And Q cannot be 0. Let's talk about this Q not being 0. Of course it's an n, but it's P over Q. We're just calling any fraction P over Q. And Q cannot be 0. Why can't Q be 0? That just means that the denominator can't. Oh, I almost stuttered. The denominator can't be 0. The denominator can't be 0 because if the denominator is 0, then your fraction is undefined. So that's what we know. So take a look at some of the examples on the screen on your slide, which is 4 over 5, 4/5. Obviously, 5 isn't 0. 8x squared over 2. And of course, that last one, negative y cubed plus 6y squared minus 8, all over x plus 1. They're all examples of these rational expressions. Okay? So let's take a look at a question. Okay, so going back to this GPA, we have Margot, who gets these certain grades in her classes. She has a 4th credit math class. Okay, so she has math, and it's 4 credits, and she has an A. Then she has bio, and it's 3 credits, and she has a B. Okay, 3 credits B, and she's got a D in something. Oh, bio lab. Good thing it's only 1 credit. 1 credits don't affect your GPA as much. Okay, and English, she's got 3 credits, and she's got a B as well. Okay, so these are her grades. So notice what it says. GPA equals this formula where A is the number of credits for which an A was obtained, B is the number of credits for which a B is obtained, and so forth and so on. All right, let's calculate Margot's GPA finally. Here's the deal. The deal is that we have to figure out how many credits she has of A's, B's, C's, and D's, and then divide it by the total credits. And she took 11 total credits, so that is N. N is 11, right? 4, 5, 6, 7, 8, 9, 10, 11. Here we go. So her GPA is 4. How many A's do we got? 4 credits of A's. Plus 3 times B. How many B's do we have? 6 credits of B's. Do you see where the 6 came from? 3 here and 3 here, 6 credits of B's. She has no C's, but she has 1 D. Okay. And that's all divided by 11. So that is, her GPA is 16 plus 18 plus 1 all over 11. That's 35 all over 11. So now we have to actually divide for her. Okay, so here we go. Does it say the nearest tenth? Yep, no, it does not. We're going to go to the nearest tenth. Okay, so 35, 11, that's 3, that's 33, remainder of 2. We get 1, that's 11, that would be 9, and we get an 8 here. So it's 3.18, which rounds to approximately a 3.2, just what I thought. So her GPA is approximately, I know my grades, 3.2. Not bad, not great, not bad, not bad. Nah, that's actually a very good GPA. Okay, except for my kid. No, I'm only kidding. All right, let's take a look at the next question. All right, we have a fraction. We want to write this fraction in 3 ways. I'm going to show you how to do that one as soon as we begin again. Okay, we're going to write this fraction in 3 ways. Well, this is one way, so you're done. Okay, here's the second way. Remember we said there's a negative fraction. There's a reason that a lot of people put this negative right in the middle. Sometimes now it's because the computer does it so nicely, but sometimes it's because they don't really know where the negative goes. Okay, because remember this, and this even says it in your workbook, if you have a fraction, and I'm just going to use 1/7, it doesn't matter if the negative's in the middle, or if the negative's on top, or if the negative's on the bottom. They're all 3 negative fractions. We've discussed this before. Okay, same thing for this. It doesn't matter where the negative is. So I could put it in the middle, or I could put it on the bottom. If I put it in the bottom, it will look like this. or I could put it on the top. However, if I put it on the top, it gets a little harder. And I'm going to do the top here, because if I put it on the top, it's actually this whole thing multiplied by negative 1 over 12. So it becomes negative x squared plus 3x plus 1 all over 12. So that's 1, 2, 3 ways you can write your fraction. And how can you check me if you want? You could take some number, let's say the number 2, and plug it in here, and you'll see you'll get the same answer whether you plug it in here, here, or here, okay? Because they're all equivalent fractions. Now, remember we talked about when will the fact that a fraction cannot have 0 on the bottom. We're going to talk about what that means for us in algebra when you have a polynomial on the bottom that has a variable. We're going to do that in a second. All right, what happens when we have a polynomial in the denominator? We have to make sure that the denominator is not 0. So here's what we do, especially when we get to higher levels of math, we have to make sure we know when that will be 0. Sometimes you can just look at it and say, well, I know that that will be 0 if x is 2. So that tells me that x cannot equal 2. That's my answer. Find any numbers for which the rational expression is undefined. X is 2 will make that undefined. So x can't be 2, because if it is, that will be undefined. Does that make sense? Because 2 minus 2 is 0. Now, let's say you can't look at it that easily. I can't look at it and tell that. Well, here's what you could do. X minus 2 is not allowed to be 0. Okay? Well, if it's not allowed to be 0, then I could just solve it just like this. Watch. Just like I did before. X, and I believe when you do the not equal to, it goes that way. So excuse me from being dyslexic. Okay, x is not allowed to be 2. So that's how I could do it. I could set the bottom not equal to 0 and just solve it like I solved before, those nonlinear equations or even the linear equations. Just solve it like I know how to solve it. Okay? All right, so let's take a look at this. This might be harder to see what will make this 0. So I may want to do this. X squared minus 25 cannot be 0. Well, now, x squared minus 25 cannot be 0. Look what happened here. This is a quadratic, so I could factor this, set each factor not equal to 0. Okay? So you do it the same way you do an equal 0. So it's x minus 5, because there's a difference of 2 squares, x plus 5. X minus 5 can't equal 0, or x plus 5 can't equal 0. X can equal 5. X can equal negative 5. That makes sense. Watch. If x is 5, then that's 5 squared, which is 25, minus 25. That would be 0. So I can't have 5. I cannot have negative 5 either, because that would be negative 5 quantity squared, the whole thing squared, which is 25, minus 25. I'd get 0 again. So these are the numbers I can't have. Okay? So let's take a look at this one. If I try to do this one, the same way, I have a problem. The problem is I can't factor that, because that's the sum of 2 squares, and there's no GCF. I can't factor the sum of 2 squares. Remember, even if I try to do this, that won't work, because I'll get a middle term. So I can't factor that. What do I do? Well, now it's time to just kind of think about this. If I have something squared plus 25, can that ever be 0? Think about this. If I have a negative and I square it, I'm going to get a positive. A positive plus a positive is never going to be 0. The only way that I can make this true is if x squared equaled negative 25. Because if x squared equaled negative 25, then negative 25 plus 25 would be 0. Well, x squared can never be negative 25 because you're squaring a number. You can never square a number and get a negative back. Because if you square 0, you get 0 back. If you square a negative, you get a positive back. If you square a positive, you get a positive back. So there's nothing that can be excluded here. So find any numbers for which the rational expression is undefined. There are no numbers that will make this undefined. So none. Because this will never be undefined. This will never be undefined. So you kind of have to just think about it. All right, so now there are a couple problems in your book that ask you to do the same thing. I want you to click off the video, try those, and we'll come back when you're ready. All right, let's take a look at this and let's see how you did. Okay, we want to know what the denominator cannot be. So it's what the variable can't be that it will make the denominator 0, because we cannot have that. So let's take a look at this. I'm going to go 5x squared minus 10x cannot equal 0. Okay, and now what I have to do is do what I did when it said equal to 0. Same thing. I'm going to pull out the GCF, which is 5x. Okay, I'm going to divide by that GCF. And we get x minus 2 cannot equal, oh, forgot it, cannot equal 0. Now I'm going to take each factor, set it not equal to 0. And remember, there are 3 now. 5 cannot equal 0, or x cannot equal 0, or x minus 2 cannot equal 0. Okay? So now we know this is garbage. This is good, but we know x can't equal 0. And now the last one, I'm going to have to add 2 to both sides. And we get x cannot equal 2. So this is what I know. X cannot equal 0, and x cannot equal 2. Because if they were either one of these numbers, this should be 0. Let's just check it out real quick. Well, if it's 0, 5 times 0 squared, which is 0. So this whole thing is 0, and this whole thing is 0. So obviously it's 0. 2 squared is 4. 5 times 4 is 20. If this is 2, 10 times 2 is 20, so that's 20 minus 20, which will make that 0. So it can't be either of these numbers, or this fraction will be undefined. Notice I never touch the numerators. I never touch the numerators because it doesn't matter what the numerator is, only matters the denominator. It's the denominator that can't be 0. Numerator is okay. All right, so let's take a look at this one. We get 2x squared minus 5x minus 3 cannot be 0. Okay? So I'm going to factor that. It's in standard form. No GCF. Here we go. 2x and x. Signs have to be different. 3 and 1 we're going to try. So let's try the 3 here and the 1 here. That's positive 1x, negative 6x. So we got it. Okay, that'll give me a negative 5x. So now I said these not equal to 0. Subtract 1. 2x cannot equal negative 1 divided by 2. X cannot equal negative 1/2. Okay, and here, add 3. X cannot equal 3. So we cannot have negative 1/2 nor 3 as our x, because if we plug in negative 1/2 here, it'll make this 0. If we plug in 3 here, it'll make it 0, and we can't have a denominator that's 0. Let's look at the last question. The last question is probably the easiest. 25 is a constant. 25 will never be 0. So it says, what numbers can I have? I can have any number I want. So there's no numbers that I have to exclude, because that's what the question says. Find any numbers for which the rational expression is undefined. And here the answer is none, because our denominator, no matter what x is, that will only change our numerator. Our denominator will only be 25. It is a constant. So let's take a look at the next question. Okay, take a look at that problem on your slide, the one that says, the one that looks really big. Okay, that problem would be a bear to do, because if we had to plug in that y, which is that big decimal, that would be such a pain. I wonder if there was an easier way to do that problem. To show you there is, I want to start with this problem. So take a look at this, and it says, explain why the rational expression can be simplified, and then simplify it. Okay, so let's explain why it can be. And you're going, what do you mean explain why it can be? I know it can be. Well, why can it be? It can be because these are all attached by multiplication. And remember, we're only allowed to reduce factors. So here's what we're going to do. We're going to reduce this. Okay? That's the black marker again. Let's try this. 2 goes into 6 3 times. 2 goes into 16 8 times. There's more x's upstairs, 1 more x. There's more y's downstairs, 2 more y's, and z has no friends. So we have, sorry z's, so we have 8x over negative 3y squared. And it really doesn't matter what a negative is. Now let me tell you, this and this are exactly equivalent. So if I gave you some numbers to put in here, and x is 4, y is 10, z is 2.1598, I don't have to plug it in here. I could plug it in here. And I think I lost my z. I do that all the time. Okay, I'm sorry, it's 8xz. Okay, but this is equivalent to this. So whatever I plug in here would work in here as well. It would give me the same answer. Okay, so just remember, the reason we can do that is because we could always reduce factors, but not terms, common factors. Okay, so let's look at some examples so that we can show you that. Okay, so let's take a look. Remember, we can reduce common factors. Well, luckily for us, we have factors here. We have the 2 factors upstairs and 2 factors downstairs. Y plus 3 is a factor. The quantity y minus 9 is a factor. The quantity y minus 2 is a factor. The quantity y plus 3 is a factor. So I can reduce factors. So I can take this whole factor out. And think about y. If y was 6, both of these numbers would be 9. 6 plus 3 is 9. So I'm just be reducing my factors. These do not match. I cannot take out the terms. I have to take out the complete factor. So on the top, I have 1 times y minus 9, which is y minus 9. And I have y minus 2 times 1, which is y minus 2. And I am done. So that's my answer. And that's it. I can't reduce anymore because I only have terms left. So I'm done. Okay, so remember, the reason we could do this and the reason we could do the problem we just did before is because we can reduce common factors, and we were reducing factors, things attached by multiplication. But here's the problem. I cannot take this x squared out with this x squared. I can't reduce it because they are not factors, they are terms. I cannot reduce terms. I need to have factors. So what am I going to do? Factor it? So here's another reason that we learned how to factor, not only to solve nonlinear equations, but because we're going to have to simplify fractions. And to simplify fractions, we need factors. So the procedure to simplify rational expressions, remember the rational expression is the fraction, okay, is to first factor everything and then to reduce out the common factors. So I'm going to do that step 1, and I'm going to factor everything. So I'm looking at the top, and I have no GCF. I'm looking at the numerator. I have no GCF. But I have 2 terms, and it's the difference of 2 squares. Right? That's an easy one. On the bottom, I have no GCF. I am in standard form. My leading term is positive, so I'm just going to factor that by making 2 sets of parentheses. And since that's a plus, it tells me they're the same as my middle, so I'm going to write the plus. X squared is x and x. Now remember, don't factor the 4. I'm factoring the 3. 3 and 1 are my only choices. I have to check for my 4. 3x plus 1x, there's my 4x. So that's my first step to reduce these. I factor everything I can. Why do I factor everything I can? Because we can only reduce factors. Okay, so now I reduce my common factors. Good night, x plus 1. Good night, x plus 1. And now my final answer is x minus 1 over x plus 3, if I write it right. X minus 1 over x plus 3. I am done. Okay? So that's how you do that problem. So there are a couple problems for you to do. Actually, before we let you do some problems, let's revisit this challenge problem. Okay? Let's see how we could simplify this challenge problem. Remember, it says to evaluate that big fraction, that big rational expression, for those values. So I'm going to erase this from the board, and then we'll do that problem. Okay, I'm not going to be so silly as to plug in those values into this. I now know I can reduce this, but I can't reduce them as they are because they're both terms. So I'm going to have to factor that. We can see that the bottom is linear, so that's not going to factor. So I'm just going to bring that over here. If it was factorable, I'd have to factor it. And I'm going to factor this. So I'm factoring x squared y plus 3x plus 6xy plus 18. Notice, I can't combine any of this. They're not like terms. Okay, so no GCF. There are 4 terms. We're going to go back to grouping this sucker. Here we go. I'm going to bring the plus down. And I got x squared y plus 3x, common factor of x. I get x, y plus 3. Okay, that's what that reduces to. And now here, I have a common factor of 6. I divide by 6, and I get xy plus 3 again. Now remember how to do this. When we group them, I look at this first term, I look at this second term, and I want to see if they have anything in common. And they have in common the x plus 3. xy plus 3. Oh, lost the y, didn't I? See, I knew it was there. Okay, xy plus 3. Sorry about that. Okay, so that's my common factor. xy plus 3. Now I divide by that, and now it's getting a little squishy down there. I'm going to use a different color. Good night. I knew it was there because I did this problem before. All right, and we get back x plus 6. I look inside here, that's linear, nothing a factor. I look inside here, nothing a factor, that's linear, no GCF. Okay, so these are my factors. X, y plus 3 times the quantity x plus 6. Now I get to my favorite part, the slash, when I get to reduce. Well, this xy plus 3 is totally like this whole thing. Okay, so I'm done there, and I have x plus 6 over 1, which is just x plus 6. Now here comes the fun part. Look what it says. Evaluate using those values. It says x is 5 and y is that big number. Who cares what y is? We don't have y any longer in our number. So now I just have to plug in the x, which is 5 plus 6. My answer is 11. Could you imagine, had you plugged in that x and a y, what a nightmare that would have been? What would you have gotten? 11. Wasn't this a lot easier? So sometimes it's a good idea to understand how to make something that looks so big into something that really can be shown that is really equivalent in a smaller way. Okay? So x plus 6, which is 11, you're done with that problem. We're going to try some more problems, and then we're going to let you try some. All right? Instructions say to simplify, but understand simplify and reduce, same instructions. I can only reduce factors. Look, I have factors here. I have the outside number factors. I have this factor right here, the x to the 10th, the x cubed, and I have this big thing, y minus 3, the whole quantity raised to specific power. Watch what we're going to do. It's really kind of easy. Watch. 10 goes into 10 once, 10 goes into 20 twice. Now with the x's, I have more x's upstairs. There are 7. Now I could do this. I could write y minus 3 out twice here, and I could write y minus 3 out 5 times here, but why would I when I understand that I can keep the base, right, and subtract the exponents. So I have more y minus 3's on the bottom, and there's 3 of them, because 5 minus 2 is 3. I know on the bottom, because the bottom exponent is bigger. So here's my final answer, 2x to the 7th over y minus 3 to the 3rd. Because 2x to the 7th times this 1 is still 2x to the 7th. These 1's are attached by multiplication, so they don't affect my answer. I am absolutely done. Awesome. I wish they were all that easy. They were easy because they were factors already. Okay? Looking at 2, we don't have that same thing going on. Here we have terms, not factors. I'm going to have to factor both the numerator and the denominator, so here we go. Okay. Already in standard form, there's no GCF in either one, so we're going to just get moving. This is a minus, tells us our signs are different. 2x squared can only be 2x and x. Okay, 6 can be 3 and 2, or 6 and 1. I'm going to try 3. Can't put the 2 there, remember, and 2. Let's see if I got it. Plus 3x minus 4x. That's going to give me a negative 1x. I don't have it. My signs are wrong. I'm very close, but my signs are wrong. Okay, so I'm going to move this. That's going to be my minus. That's going to be my plus. Okay, checking again. Negative 3x. Positive 4x is my positive x. Now for this guy. Same thing. Standard form. Leading term is positive. No GCF. That's a plus, but tells us the signs are the same as the middle, so they're both negative. 2x squared can only be 2x and x. I'm going to try 3 and 2 again. Let's see what we got. We got negative 3x, negative 4x, which is negative 7x. So it's a done deal. We're done there, factoring. Now we just reduce common factors. Good night. I cannot reduce these, but these are not the same. They have to match completely. Okay, let's take a look at this. So our answer is x plus 2 over x minus 2. I love that 1 for some reason. The 1 keeps getting in my head. X plus 2 over x minus 2. And I can't reduce anything left because now we just have terms. And that's it. That's the end of that problem. I'm going to try the next 2, and then I'm going to let you do some on your own. Okay, just so you know, I'm getting a rash already. This looks totally backwards to me. Okay, I'm telling you what I would do. This is what I would do. I would go, all right, I want to really look at this. This is negative c plus 9 if I write it in standard form, which means that the constant term goes last. But now, yes, I have another rash. And I have another rash because there's a negative there. So what I would probably do is go c minus 9, pull out a negative 1. When I divide by negative 1, I change all the signs, I get c minus 9. Oh, boy. And now look, this matches that totally. That entire c minus 9 is gone. I'm going to show you why this works the way it does in a minute. And that's 1 divided by negative 1 or just negative 1. Do you know why that works that way? That works that way because these were totally opposites. C, negative 9, positive 9. They are opposites, totally different signs. Every term must have a different sign for them to be opposites. Because they're opposites, anytime you divide opposites, you're going to get negative 1. Okay, if you could see that, great, but if you can't, we got it right there. If you can see it, awesome. If you can't, that's okay too. You can work around. Now listen, I didn't pull this stuff out and turn it around because I wanted it to reduce. I pulled it around so I could look at it better, okay? But they are opposites. Again, opposites are when every single sign is different. Every single C, the letters, the numbers are the same, but the signs are different, okay? That's why you got negative 1. Let's see this guy here. Yeah, I seem to be getting a rash. Okay, I'm going to take care of that in a minute. I want to take care of the top. All right. Because you may or may not see something. Okay, it's in standard form. Leading term is positive. We're factoring so we can reduce. 2x can only be 2x. 2x squared can only be 2x and x. Signs are different. 3 could only be 3 and 1. That's a positive 3x, a negative 2x. That'll work. Now, if I put the 1 minus x there, you may be able to see this. You may not. If you can, notice these are opposites. X have opposite signs. 1s have opposite signs. You can cross this out, and you'd have to make 1 negative 1 somewhere. You can do that. I tend to be careful about that because that scares me a little bit. So what I tend to do is say, all right, this makes me crazy, and I tend to rewrite it. But if I rewrite it, then what happens is I have to pull out a negative 1. So that's what I'm going to do. I'm going to do that. If you see it, that's fine, but I'm going to not see it. Okay, so I'm going to pull out that negative 1. When I pull out the negative 1 and I divide by negative 1, I get x minus 1. Now I can see it. Okay, so now I absolutely see that they are the same. Good night. I get 2x plus 3 all over negative 1. Do not go away. You should not leave a 1 in a denominator no matter what, whether it is a positive 1 or a negative 1. But you can't just get rid of it. Remember, this means it's for both of these. So my final answer is 2x divided by negative 1 or negative 2x, positive 3 divided by negative 1 or negative 3. That is my final answer. How you get there is up to you. But notice that when you cross these out, had you crossed them out without turning them around, there's only 1 negative 1. Okay, so be careful of that. I like to turn it around, but that's absolutely up to you. So that's how you do number 4. Okay, now there are 3 problems left, and I want you to try those, and then we'll look at them together. All right, here we go. Well, we already have factors, so I hope you saw that. We can just reduce. 7 goes into 7 once, 7 goes into 21 3 times. X minus 2, same base. Okay, that's to the first power, that's to the second power. So we have one more downstairs. So this is just x minus 2. Our answer is 1 over 3 times the quantity, x minus 2. And we are done. Okay, let's take a look at this. Here, remember our first step is GCF. There is a GCF. It's 10. So if we divide by 10, we get m squared minus 1. Actually, it's 10m. I apologize. 10m. Let's try that again. It's 10m. If we divide this by 10m and this by 10m, we get m minus 1. Okay? On the bottom, we have a GCF. It's 5. If we divide them both by 5, we get m minus 1. Oh, how convenient. Okay? Now we can reduce. 5 goes into 5 once. 5 goes into 10 twice. The m has to stay, but these m minus 1s go. On the top, we have 2m. On the bottom, we have 1. Don't need to write the 1 because 2m divided by 1 is obviously 2m. Okay, I want to take a closer look at this because 1 would actually make this undefined because m minus 1, 1 minus 1 would be 0. 5 times 1 is 5, minus 5 would be 0. So if m was 1, this problem would be undefined. So this problem is equal to 2m all the time except when m is 1. That's what's really going on here. We haven't really discussed that much. We don't at this level. But later on, that's what you have to understand. That yes, these are the answers, except for those numbers that make those denominators 0. Okay? Okay, so let's take a look at this one. Rash. You're feeling my pain, aren't you? Okay, because that's got a leading negative. Okay, so I'm going to pull that out. Negative 1, There's no other GCF. Divide through by -1, all the signs change. Y squared minus 4. Okay? Well, guess what? I know you see it. That is the difference of two squares. I'm going to write this down here. But now I have to factor that. Difference of two squares. Y and y for y squared, 2 and 2 for 4. Signs are different over this. And now we get to reduce. Good night. And I have as my final answer, ready? -1 times y minus 2 over y plus 2. This is my final answer. And they are not opposites. Let me tell you why. Because this doesn't match this. If they were opposites, they would. Because this is -y plus 2. So you are done right there. You are done right there. So we go from here to here, back to here. Okay? That's it. Okay, so that's the answer to that problem. I hope you got them all. That's the end of simplifying. That's how easy it is. You just factor, reduce. Because remember, you cannot reduce terms. We saw that when we gave you some problems the other day with addition and multiplication with numbers. Okay? Okay, so that's it. And that's the end of lesson 2. Right now on to lesson 3.